Hi, today we'll discuss about the Verilog lecture series, 30 days lecture series. Today we'll see the this day 6. Okay, day 6 is we will discuss the RTL code and Testbench for the encoder. So I will show you how to execute in EDA Playground and Xilinx Vivado and Quartus Prime and ModelSim. Okay. So if you see the program, first I will explain the program. So this is first we'll see. Yeah. So first we'll see the code for 422 encoder. Okay. So if you see this code for 422 encoder, this is the code for 422 encoder. So if you see module encoder 422, this is my module. And what is my module name? Encoder 422. And I need to declare. So 422 encoder have 4 inputs and 2 outputs. So I'm declaring with a vector input 4 down to 0 in and output. So reg. So this out I am using in the behavioral style. Okay, this is the behavioral modeling. So this out variable I am declaring in I am using in the procedural block. Okay, so that's why I am using this out reg 1 down to 0 out. Okay. So output reg 1 down to 0 out. Okay. So this is what how many bits? 2 bits. Okay. So here I declared the input and output always at the rate star. So star means what? Implication operator. Okay. So it will be like so if you are not declaring any input, it will be applicable for all the inputs also. Okay. If there any change in that inputs, then there is a change in the output. Okay. So always at the rate star begin case in. So I'm using case statement. Okay. So based on the truth table only. So in the encoder, we know that at a time any one of the input is 1, and it will produce the output of that binary equivalent of that output. Suppose here y0 is 1. So that means y0 means 0 means what is the binary equivalent? 0 0. Okay. Y1 is 1 means 0 1. Y2 is 1 means 1 0. Y3 is 1 means 1 1. Okay. So here this is what 0 0 0 1. The out is what 2 tick binary 0 0 and 4 tick binary. So if it is 0 0 1 0, out equal to what 2 tick binary 0 1, and this is 4 tick binary 0 1 double 0 means out equal to 2 tick binary 1 0 and 4 tick binary 1 1 triple 0. So y3 is 1. So it will give the binary equivalent. And there is a default statement will be there. So why it is default statement means if you are not giving a default statement, it will infer as a latch. Okay. So for every case statement, there will be a default statement. So out equal to what 2 tick binary XX. Okay. End case, you need to end the case, and here begin is there. No, you need to end and end module. Okay. This is my code for the 422 encoder. And coming to test bench. So module, what is my module name? TB underscore encoder 422. So I'm declaring the test bench variables. Reg 3 down to 0 in. This is a 4-bit input. Wire 1 down to 0. Okay, this is out. So I need to instantiate my design in the test bench. So what is my design name? This is our design name. This design name and this design name should match, and followed by the instance name, and this is connection by name. Okay, the variables outside the bracket are input and output. The variables inside the bracket are test bench variables. Okay, initial begin, and these are the commands or instructions for executing the waveform in the EDA playground. $dump file encoder underscore 4 underscore 2 dot VCD $dump vars 0 comma TB underscore encoder underscore 4 underscore 2. Okay. So $monitor is a system task. If there any change in the variable, either it may be in or out, it will display. Okay. So if you see the advanced Verilog topics like event scheduler, so it will be displayed in the postpone region. Okay. So at last it will display every time if there any change in this variable, and it will display. Okay. So I'm giving the stimulus. So in equal to I'm giving 4 tick binary 0 0 0 1. After 10 time minutes, again, this is a delay I'm introducing. So here I given the time scale now. Time scale is 1 nanosecond by 1 picoseconds means. So 1 nanoseconds is the delay. Okay, 1 picoseconds is the precision. Okay, so precision means if it is a decimal value, it can round up or it can means it can make the round up or truncated like that. Okay, so 1 nanosecond means 10 means what I am giving the delay 10 nanoseconds. Okay, so I am giving 0010, 0100, 1000. Okay, so 111 also I am checking. Okay, so when all inputs are 1, the encoder will produce the wrong output. But in the design, I checked the default case now. So normally this case here it will give as a don't care only. Okay, and the dollar finish is to terminate the simulation and end module. Okay, so this one I'm executing in the EDA playground. How to execute? Just to open this EDA playground. Okay, 1 second. So I'm opening the EDA playground. You press I editor mode. Just copy this code and go to EDA playground. Here right side I need to add the code and left side copy this code and go to this EDA playground. Okay, this side I need to write the test bench. Okay, next go to tools and simulators. Need to select Altec Rivera and open EP waveform after run. Sorry, open EP waveform after run. Okay, so save this code and run this. So I got the, so if you want to see radix in binary, okay, so it is giving like so in equal to 1 means so out equal to what 0 you are getting, 10 means 1 you are getting, 100 means 10 you are getting. Okay, the binary representation you are getting. Okay, 100 means what y3 is 1, you are getting 1 1. Okay, and if it all are ones means we need to go for priority encoder. Okay, so there depending on the priority it will give the output, but here we are checking for only simple encoder, so default case is what XX only. Okay, so like this we can see, and we can see in the log file also. See here, in equal to 0001, out equal to 00, in equal to 0010. Here y1 is 1, 0 1, in equal to 0100 and y2 is 10, in equal to 1000, out equal to 11, and in equal to 4 ones, out equal to and XX. Okay, so like this we can see the output. Okay, next I'm executing in the EDA plate. Go to project, new project. Next, so what is my, to choose the location. So we are in day 6 now. Okay, select next. This is my RTL project. Create my file. Okay, so give the module name only. So this is my module name. Copy this, paste, and choose the location. So in this encoder is my location. Okay, next and next. Finish. And same, I'm giving the module name also. So this is my encoder. Here, if you see this one, copy this code and paste over here. Save. and go to the simulation, add or create the simulation source, create the file name. Here we need to give the Testbench file name. Copy this and here paste, choose the location, encoder, select OK, finish, and OK. Yes, my Testbench file is created. Okay, and copy this Testbench file, Testbench code. So copy this, and here you can paste. 1 second. Here you can paste my code, Testbench code. Save. So my Testbench file is my design file is instantiated in the Testbench. Okay, what is my design name? Encoder underscore 4 underscore 2, and instance name is DOT. Okay, why? Because in the Testbench I given this instance, connection by name. No, this one. Okay, this one I gave. So that's why it is instantiated. And go to elaborate the design. Okay, open the elaborated design. I want to see the hardware, how the tool is converting your code into gate level netlist. So this is my encoder. Okay, so like this means 4 inputs are there, 2 outputs are there. Go to run simulation, run behavioral simulation. You can see in the TCL console also. So in is 0 0 0, out is 0 0. In is 0 0 1 0, out is 0 1. In is 0 1 0 0, out is 1 0. In is 1 0 0, out is 1 1. And all ones XX. Okay, and you can see in the here also. So you can see so radix binary. Here also radix binary. So here every 10 minutes I need to see the output. 0 0 0 1, out is 0 0. 0 0 1 0, out is 0 1. Okay, so here y1 is 1. That binary representation you are getting. Okay, here y2 is 1. 0 1 0 0. You are getting 1 0. 1 0 0. You are getting 1 1. Okay, so all are ones means what? A default case you will get. That is don't care. Okay, so like this we can see the simulation in the UI. Okay, and coming to the Quartus Prime, open the new project. Next, and choose the location where you want to store this project. Okay, so and here 30 days, and we are in day 6 sim. Select this folder and give the so I created 3 folders: RTL, sim, and TB. Okay, in RTL I wrote the RTL file. Okay, so here open this encoder 422, this file name, encoder 422. Next, empty project. Next, so add the RTL file. Okay, so if you see day 6 RTL encoder 422. Okay, next select one FPGA family. Okay, finish. Now it is added, and go to analysis, start. Yeah, okay. So 0 errors I got. Next go to this netlist viewer, RTL viewer, open. So I got like this. Okay. So this is what Quartus Prime. Okay, I got. So in terms of success, it is converting your code into gate level netlist. Okay, and coming to this ModelSim. So file, new project. I want to close this. So what is my project name? So give the this only encoder. Project name is encoder. Choose the location. We are in day 6 now. So day 6 sim. Okay, okay, and add the existing files. We are in day 6, RTL, encoder 422, okay, again, one second. Here I will delete this. Next go to TB, add the TB file, okay, close, select these two, right click, compile selected. So two are compiled, go to work, and this TB I need to simulate. So next go to this encoder, right click, add wave. Okay, so you can here this wave is there. No, just here two signals are added. Go to DUT, add wave. Okay, so you can group this TB files. Right click, so group TB. Okay, and next right click, group DUT. Okay, and go to run. Okay, run all. Okay, so you got the output. So you can see in the TC transcript window also. In is 0001, out is 00. Okay, so y0 is 1. Okay, that binary representation you are getting. In is 0010, out equal to 01. Okay, so y1 value binary representation you are getting 0100. So 10. Okay, y2 value you are getting 1000. Y3 value you are getting. If it is 1111, you are getting X. Okay, you can see in the this one also. So here if you see, yeah, just expanding, zoom fill, here you see. So when Testbench signals you see. So 0001, the out is 00, 0010, 01, 0100, 10, 1000, 11, and 1111 means you are getting X. Okay, so like this we can see in the ModelSim. Okay, so next if you quit under hyphen sim means it will come out from the simulation. Okay, so like this we can see in the ModelSim. And next we'll see Octal-to-Binary Encoder. This is actually 8 to 3 means 8 to 3 encoder. Okay, so 8 to 3 encoder means Octal-to-Binary Encoder. You are declaring input with 8 bits, 7 down to 0 octal, output reg 2 down to 0 binary. So why it is reg I am using in the procedural block, that's why I am using reg. Okay, reg data type 2 down to 0 binary, always at the rate star case octal. So if it is 8 bits 00, so this 1, then it will get the binary representation of y0. Okay, so that is 000, and y1 is 1 means 001, y2 is 1 means 010, like that. Y6 is 1 means 110, y7 is 1 means 111. Default is what 3 ticks binary xxx. So end case, end and end module. Okay, this is my code. Okay, coming to the test bench, So module, my test bench, this is my test bench name, and I need to declare the internal variables of the test bench. So reg with octal with reg data type. So reg 7 down to 0 octal, and binary with y data type, y2 down to 0. I need to instantiate my design. Okay, how to instantiate? This design name and this design name both should match, followed by the instance name, and this is connection by name. Okay, the variables outside the bracket are design inputs and outputs. The variables inside the bracket are test bench variables. Okay, so this is the instructions for executing the waveforms in the EDA playground. Dollar monitor means every time if there any change in the octal or binary, it will display. This is a system task. And octal, so every 10 minutes I'm giving this different values, stimulus. Okay, last value also I'm checking whether I'm getting proper output or not. So here this is what ambiguity, so means all inputs are one, so means encoder can't identify. Okay, why? That's why I given the default case, it will give xxx. Okay, dollar finishes for means terminate the simulation and end model. Okay, so this one I'm executing in the EDA playground first. So just copy this. So go to EDA playground. So open the new one, and here you paste, and next go to test bench. Copy this, and here you paste. Go to tools and simulator, select Aldegree Vera, and open EPBFM, and save and run. So I got the waveforms. Okay, here radix, if you give binary, here you will get. So if it is this is what this is actually 3 bits. This is what 8 bits. Okay, you can expand this. So if it is 0 0 0, so means I0 is so 0 0 means what? So I0 is 1, remaining all are 0 only. 0 0 1, I1 is 1, remaining all are 0. 0 1 0, I2 is 1. Okay, and 0 1 1, I3 is 1. 1 0 0, so this one. Okay, octal input. So this so you are getting 1 1 0 0. Okay, so the binary representation you are getting. Okay, all ones means you are getting X. Okay, so you can see in the log file also. So here I0 Y0 is 1 means you are getting 0 0 0 binary representation. Y1 is 1 means 0 0 1. Y2 is 1 means 0 1 0. Y3 is 1 means 0 1 1. Y4 is 1 means 1 0 0. Y5 is 1 means 1 0 1. Y6 is 1 means 1 1 0. Y7 is 1 means 1 1 1. So all are ones means it will not give proper output. That is default statement. That is case X. Okay, default case statement. I declared the X. No, this one. Where here default binary equal to what? XXX. So other than this, it will execute XXX only. Okay. So you can see in the Vivada also. Just to close this, go to the design source, add the design source. Next, create the file name, Octal-to-Binary, copy, and here you paste. Choose the location, encoder, select OK, and finish OK. Yes. So this is my Octal-to-Binary. So go to this, copy this code, and here you paste, save. I want to see this circuit. I need to make right click, set as top module, and go to simulation, add the simulation source, create the simulation, that means test bench. Testbench you need to copy. Okay. So Testbench. So choose the location that is encoder. Select OK. Finish. Okay. Yes. So this is my TB file. So go to this. Here you copy this TB file and here you paste, save, right click. I need to make a set of stop. Why? Because octal to binary encoder I need to simulate now. So that should become the top module. Okay. Set as top. Octal to binary it becomes top module. So next open elaborated design. How the tool is converted your code into in terms of gate level netlist. So like this it is converting. Okay, 8 inputs and 3 outputs. Okay, run simulation, run behavioral simulation. So you can see in the TCL console also. Okay, these are the, so whatever we seen in the EDA playground, same thing we are getting. Okay, so y0 is 0, the binary representation it is getting. y1 is 1, 0 0 1, y2 is 1 0 1 0, like that. y6 is 1 1 1 0, y7 is 1 1 1 1. All are 1 means don't cares you are getting. Okay, so you can see the in the waveform also fit to page. I want to see in the binary. You go to radix binary, and here also go to radix, and I want to display in binary. Okay, so here this y0 is 1 0 0 0, y1 is 1 0 0 1, y2 is 1 0 1 0, like that. Y7 is 1 1 1 1. All are ones means you are getting don't care. Okay, this is saying in the VBAD. Okay, go into this Quartus Prime. So just file. One second. Go to file, new project wizard. Okay, so I want to close this. Next. Okay, I'm in same folder only. So here I created RTL. Here RTL I created now. This file. One second. Here this is my RTL file. This module name is there. No? Just you copy this. Copy and you paste over here. Next. And next. Add the RTL file. Okay. So RTL octal to binary open. Next. Select any FPGA family. Next. Next. And finish. So go to analysis and synthesis. Start. Yeah. So 100% I got 0 errors and 1 warning. And go to analysis and netlist viewer. The netlist viewer, RTL viewer, open. So like this, my code. So it is converting in terms of encoder like this. Okay. So this is Quartus Prime. Coming to the ModelSim file, and here here we are in project. No, yeah, we are in project. So file, new project. Okay, I want to close this. So give the module name only, octal to binary. Copy this, and location is same only. Okay, location is we are in the day 6 only. Okay, day 6 is sim folder. Okay, okay. Okay. Add the existing files. RTL octal to binary. Okay, and go to the TB TB files, octal to binary TB file also you upload. Okay, close, and next right click, compile selected. Okay, yeah, you got tick mark. Next go to library, and octal to binary TB is there, no? Right click, simulate. So go to this octal to binary, add wave, and here waves, here we add the wave. Okay, and DUT files also add wave. Okay, so just here we can group the inputs TB and DUT files. Right click, group, these are TB files, and here these two, right click, group, these are DUT files. Okay, okay, and expand this. Next zoom fit, run all. Sorry, here we need to run this code, no? So run all. Okay, now I got this. So zoom fit, you got this. Okay, so 0 0, so this y0 is 1 means 0 0 0, y1 is 1 means 0 0 1, y2 is 1 means 0 1 0, y3 is 1 means 0 1 1, y4 is 1 means like 1 0 0 1 0 1 1 1 0 1 1 1, and don't care. Okay, and next you can see in the transcript window also. So octal, y0 is 1 means 0 0 0, y1 is 1 means 0 0 1. Okay, here so y3, y2, y3, y4, y5, at a time any one of the input is 1. Okay, for the encoder, this is the 8 to 3 encoder. Okay, so if it is xxx, binary value is xx7. Okay, so like this we can see the 4 to 2 encoder and 8 to 3 encoder we seen in the EDA playground, Xilinx Vivado, and we see in the netlist, gate level netlist in Quartus Prime, and we see in the simulation simulation waveforms in the ModelSim. Okay, thank you.